You guys can follow me. Let's go.
Pull out them eyes. Go down there, why not go down there? Go down there, why not go down there? Go down there, why not?
Hi, we're from Group B and I'm member number 1. My name is Adlina Zaira bintu Zaimi and we choose UMK Lake as our event.
Hi, I am member 2. My name is Akila Munira binti Syam.
Hello, I am member number 3. Nasimi anak perempuan bola Sega.
Hello. I'm member 4. My name is Nur Inshira binti Muhammad Hafizi.
Did you know how far this stone can go?
No.
Okay, I will give the derivative solution. So, a stone is thrown from ground level near the UMK Jeli campus lake. The stone follow a parabolic path given by the equation ht equal to negative t plus 20t plus 2, where ht represents the height of the stone in meters and time t in second. So, find the maximum height reached by the stone and the time at which it reached the height.
Wait, what the solution?
So, to solve this, we need to find the maximum height reached by the stone. We need to determine the vertex of parabolic path. The vertex corresponds to the highest point on the path, which represents the maximum height. So, for the first step, we need to find the derivative of the height function with respect to time. So, h differentiate t equal to d over dt negative 5t plus 20t plus 2 equal to 2 minus 5t plus 20 equal to negative t plus 20. Step 2, we need to set the derivative equal to 0 and solve for t to find the time at which the stone reached its maximum height. So, negative 10t plus 20 equal to 0. So, t equal to 20 divide 10. So, t equal to 2 seconds. So, for the last step, we need to substitute the value of t into the height function to find the maximum height. So, ht equal to negative 5 power 2 plus 20t plus 2. So, we know t equal to 2. So, we just need to replace t with 2. So, h2 equal to negative 5, 2 power 2 plus 2 times 2 plus 2 equal to negative 20 plus 40 plus 2. The answer is 22 meters. So, the stone reached a maximum height of 22 meters at 2 seconds after being thrown. So, thank you.
Another problem that we found at this place is how much maximizing the height of a water fountain. So, you all can imagine a water fountain is installed at UMK Lake that shoots water straight out into the air. The height of the water column is modeled by the equation ht equal 18t minus 4t square 2, where h is the height in meter and t is the time in second. Then, at what time will the water reach its maximum height and what will the maximum height be? That is our problem. Okay, let me explain more about the solution of the problem. First of all, to find when the water will reach its maximum height, we can different ht with respect to t and set it equal to 0. dh over dt equal to 18 minus 8t equal 0. Then after we divide 80 to 8, we will get the answer t equal 2.25 seconds. So, the water will reach its maximum height after 2.25 seconds. At the last part, to find the maximum height, we can substitute t equal 2.25 into the equation for h. So, equation we use is ht equal to 18t minus 4t square 2 and h 2.25 equal to 82.25 minus 42.25 square 2. Therefore, the water will reach a maximum height of 20.25 meter after 2.25 seconds.
The third problem is the depth of the university lake measured from the surface to the lake bed is given by the function ht equals 25 minus 0.4t, where t represents time in hours since the observation started. Determine the rate at which the depth of the lake is changing after 6 hours. Okay, the solution for this problem is to find the rate at which the depth of the lake is changing water after 6 hours. For first, we need to find the derivative of the depth function with respect to the time dh over dt. Given that ht equals 25 minus 0.4t, we can differentiate it with respect to t to find dh over dt, which will be dh over dt equals d in bracket 25 minus 0.4t over dt. Using the power rule of differentiation, the derivative of 25 with respect to t is 0, since it is a constant, and the derivative of the negative 0.4t with respect to t is negative 0.4. So the dh over dt is negative 0.4. So the rate at which depth of the lake is changing after 6 hours is negative 0.4 units per hour. This means that the depth of the lake is decreasing at a rate of 0.4 units per hour after 6 hours.
Okay. Alright, now it's so hot guys, so the lake water in UMK will automatically become shallow. So, let me see. Alright, let me explain to you guys. The water level of the university lake is changing over time. The rate of change of the water level in meters per hour is given by the function ht equal 3t square negative 6 plus 2. So, determine the initial water level at t equals 0 and the initial rate of the water level. Part 2. I need to explain to you guys about problem solution. Alright, so step 1, we need to find the initial water level. We evaluate ht at t equals 0. h0 equal 30 square 2 minus 60 plus 2 equal 2. Alright, next, let's move to step 2. Therefore, the initial water level is 2 meters. Alright, to find the initial rate of change, we take the derivative of ht with respect to t. Let's move to step 3. ht equal dh over dt equals 6t minus 6. So, last step is step 4. You guys should know evaluating ht at t equals 0. h0 equals 60 minus 6 equal negative 6, and the initial rate of change of the water level is negative 6 meter per hour guys.
Much later.
So beautiful. Ina, come here.
Yes?
Why is this lake so deep? Why?
Oh my god, Inshira. That is the reason why it calls lake. Because it suits for our aqua ecosystem.
Oh, I see.
Yes.
Alright, thank you Ina.
Welcome.
You're so fantastic girl.
Of course.
Yeah, now we on the way to
Another lake that we want to compare with our chosen lake. Let's go.
Let's go. The lake in the Fiat building is not suitable for recreation because there are dangerous animals.
compare the lake in the Fiat building with this lake, it is more suitable for recreation because there are few trees and no bush area. Moreover, this place provides jogging tracks that are suitable for cycling and jogging in the evening.
Thank you for watching, guys. Don't forget to like and subscribe. Thank you. Bye.